Okay, so let's do this FE type example where we're using the interaction diagram, specifically column strength interaction diagram for rectangular sections with bars on the end faces. So using that diagram, we know we're going to have to solve this question, and specifically this diagram is given on it's going to be page 162 in FE Handbook 9.5. So in the new FE Handbook 10.0, it should be on page 278, and that's the diagram I'm going to be using for this type of question. So first, we know we have a 14 by 22 column, and it is to support an ultimate load P sub u of 250 kips and a factor moment M sub u of 5000 kip inch. We're going to assume R sub n is 0.227. So when you see this R sub n, you can automatically think that we're going to use the diagram because that's the only location that's given. That's the only time I see it in the FE handbook. So we're given this value. We know F sub y is 60,000 psi, F prime c is 4,000 psi, and the area of steel. So the question asks us the area of steel in inches squared required to resist the actual load and moment is most nearly what? So what is the area of steel required for this column? So that's our unknown. And what do we do first? So first, we know that by definition, if you look closely on it's going to be page 159, that the ratio for the total reinforcement area to the cross-sectional area of a column is given as rho sub g, and that's going to equal to the area of steel divided by A sub g, the gross area. What's the gross area? It's just going to be simply the 14 by 22. So we're just looking at a square, right? It's just a rectangular cross section, and it's going to be 14 by 22. So let me use that. 14 by 22. And these are in inches. So it's going to be about 308. This is 308 inches squared if you do 14 times 22. So we know we have this value for A sub g, and we want to determine A sub s, but we don't know this rho sub g, and we need to use the diagram to find this rho sub g. So we'll do exactly just that. And the diagram, if you look closely, for the y-axis we have K sub n, for the x-axis we have R sub n. K sub n is it's denoted for the axial force, and R sub n takes care of the moment. So we need what? K sub n, because R sub n is given, which is nice, as 0.227. So R sub n 0.227. And now we want to find K sub n. That we do not know. So we can simplify that by using the following equation. We take P sub u over phi, a reduction factor, times F prime c times A sub g. So P sub u is going to be given, right? It's up here. It's 250 kips. So plug that in. Note here everything is in kips. Divided by our phi. And this value, the reduction factor, since we're looking at a column, it's going to be in compression. And for compression, always assume phi is 0.65. 0.65. F prime c for concrete is given to be 4,000 psi, but no, it's in psi, so we need in ksi, right? So you divide by 1,000, so it's going to be 4 ksi for the kips, right? Times A sub g, which is the 14 by what? 22. So 14 times 22 should give you 308 inches squared. So the units look good. Everything is in kips and inches. We're good. So now we can solve for K sub n. I'll just write it down here. And I got about 0.312. So we have our K sub n now. We have our R sub n, the two variables. For the x-axis we have this. For the y-axis we have this. Now we'll go into our diagram we look at it closely in our FE handbook, we know our R sub n is 0.227. So this is 0.2, this is 0.22, so we're gonna make a line there. And if I use my line tool, so we're just gonna go up, and our K sub n is 0.312. So we're going, this is 0.3, 32, 31 is very close, so it can be here. And these both intersect at this point, right? And this point is closer to this line. And this line, if you look, it's gonna go up to, this is the 0.2 row line. So for row, it's gonna be the 0.2 intersecting at this point. So 0.1 is going to be this line, but it's much closer to the 0.2, and we're gonna say row is going to be our 0.2. So now that we have row, we said it's going to be our 0.02, sorry, not 0.2, 0.02, based on that diagram. Our only unknown is A, the area for steel, so it's going to be 0.02 equals to our 308 inches squared, and we have A, the area for steel on top. We can solve for area for steel, and I got about 6.16 inches squared, and this is the area of steel required specifically for this column. So note here, we're gonna have to put this area of steel, I'm just assuming here, in this column to resist the actual load and moment that's given in the question. So our correct answer is C.